Hello everyone. Today we're going to be solving Aqa GCSE Chemistry Specimen 2018. Today we'll be solving Chemistry Paper 2F. This particular question paper contains 12 questions. In this particular part 1, we're going to be solving from question number 1 to question number 6. This question is about mixture and analysis. Which two substances are mixtures? So we know that air is a mixture. Air is a mixture of many different gases. Carbon dioxide is a pure substance. Graphite is a pure substance. Sodium chloride is a pure compound. Steel is a mixture of carbon and iron. Steel will also be a mixture. Draw one line from each context to the correct meaning. Pure substance in chemistry. A pure substance in chemistry, a substance that had nothing added to it. Well, a substance can already be mixture of many different substances. That can still be pure. For example, baby food or milk. Alright, if nothing is added to it, like water or any other additive like milk powder or whatever, then it's a pure substance. Like it's a day-to-day life thing, pure substance. But in chemistry, a pure substance must contain a single element or a single compound. Pure substance in everyday life. Pure substance in everyday life are the one, for example, substance that had nothing added to it. What is the test for chlorine gas? If we want to test for chlorine gas can be tested with damp litmus paper. As we put the damp litmus paper, for example, if we put a damp blue litmus paper, initially it turns red and then it gets bleached, so it will turn white. A student tested a metal chloride solution with sodium hydroxide solution. A brown precipitate is formed. A brown precipitate is an indicative precipitate of iron 3. So iron 3 is present in the solution. What was the metal ion in the metal chloride solution? Iron 3. By the way, guys, if it would be calcium, probably it wouldn't give any precipitate. The most likely precipitate is going to be white. Copper, it would give a blue precipitate. Iron 2, give a green precipitate. The word equation shows the reaction between anhydrous cobalt chloride and water. Anhydrous cobalt chloride plus water produces hydrated chloride, which is pink in color. Name the type of reaction shown with this symbol. This symbol shows a reversible reaction. When the student added water to anhydrous cobalt chloride, what happened? So anhydrous cobalt chloride, which was blue in color, it took the water, it got hydrated and became pink color. So the color changed from blue to pink. A student measured the temperature rise when anhydrous cobalt chloride was added to water. The student's results are shown in table 1. You can see in trial 1, the temperature rise is 8.5, 8.2 and 8.2 in trial 3. That was the mean temperature rise. So we're going to add this 3 and then we're going to divide by 3. So 8.3 degrees Celsius. When water was added to anhydrous cobalt chloride, an exothermic reaction took place. Name the type of reaction when hydrated cobalt chloride reacts to form anhydrous cobalt chloride and water. If a particular reaction is reversible, then going forward, for example, going from anhydrous to hydrated is exothermic. Then the reversible reaction going from hydrated back to anhydrous will be endothermic. So it will be endothermic. Gold is mixed with other metals to make jewelry. Figure 2 shows the composition of different carat values of gold. We can see different carat values. For example, 18 carat contains way more gold than 9 carat gold. What is the percentage of gold in 12 karat gold? We can estimate it, because 9 carat is equals to close to 40%, which is 37%. And 18 carat is 74%. So it will be in between that. So it's not going to be this 3, and it'll be 50%. Give the percentage of silver in 18 karat gold. Use figure 2 to answer this question. So 18 karat gold, let's see, silver is represented by this middle portion. So we can see it represents 3 boxes. That means 6%. Suggest 2 reasons why 9 karat gold is often used instead of pure gold to make jewelry. The cost for 9 karat is much cheaper, and pure gold would be 24 karat gold would be much more softer and therefore easily it will bend. If we make a jewelry out of it, the jewelry will not be rigid enough to sustain constant wearing and all the troubles that a jewelry needs to go through. And the other thing is it may change color. So that's also another problem. A student investigated a food coloring using paper chromatography. Put a spot of food coloring X on the start line. Put spots of 3 separate dyes A, B, C on the start line. Place the bottom of the paper in the water and leave it for several minutes. Figure 3 shows the apparatus the student used. Start line drawn in ink. We have water. We have the lead. Give 2 mistakes the student made in setting up the experiment. What is the mistake in here? First of all, we can see that the student has put the start line underneath the water. All right, the student has submerged the start line underneath the water. So all of these substances will wash away in water. The second mistake, we can see that the start line is drawn in ink. The start line should be drawn with a graphite pencil. So two mistakes, the start line was drawn in ink, water level was above the spots. Another student set the experiment up correctly. Figure 4 shows the student's result. Solvent front, chromatography paper, start line. How many dyes were in X? We can see X consists of 3 different spots. That means there were 3 dyes. Which dye ABC is not in X? So X does not contain A. We can see because if we draw a parallel line, we do not find a spot in X for A. Use figure 4 to complete the table 1. Calculate the value of for RF for dye A. Distance moved by dye A. Distance in millimeter. So distance in millimeter, we would have to calculate for dye A. Now, guys, because we are doing it in a tablet, it will not be possible for us to measure. However, we can see the mark scheme and do it. So this one was 38 millimeter. The second information asked was distance from start line to solvent front. So distance from start line to solvent front would be this distance, and that was 102 millimeter. Use the equation RF is equals to distance moved by dye A divided by distance moved by solvent. Give your answer to 2 significant figures. So we have to calculate the RF. We're going to write RF is equals to 38 over 102, which will give us 0.37. In 2 decimal places, this is the answer because they say 2 significant figures. The original answer is 0.37254, which we can round it up to 0.37. Greenhouse gases affect the temperature of the earth. Which gas is a greenhouse gas? Now, we know that argon is a very unreactive gas. Nitrogen is, the gas that is needed for making nitrates of soil. All right. It's also very unreactive gas. Oxygen is what we breathe in, breathe out. We breathe in oxygen and then trees, they give off oxygen. Methane is the one which is the problem, increase in the global temperature. An increase in global temperature will cause climate change. What is one possible effect of climate change? When climate changes, it can lead to sea level rising, because climate change can heat up the ocean, and as water is heated up, it expands in volume. So when water expands in volume, basically the sea will expand in volume as in overall, in which sea level will rise and we will drown. Another theory is, there are a lot of ice that is trapped in the ice caps of the North Pole and South Pole, and those ice, when they are going to melt, they are going to get added to the ocean water, which will further increase the volume of the ocean. Carbon dioxide is also a greenhouse gas. Figure 5 shows how the concentration of carbon dioxide in the atmosphere has changed since 1850. Okay, we can see gradually starting from 1900s, all right, 20th century, it increases dramatically, very, very fast. So the last 100 years or so, we can see a faster increase. Which process is the reason for the change in carbon dioxide concentration? Definitely in the last 100 years, we have started to burn fossil fuel the most. So burning of fossil fuel. Give 3 conclusions that can be made from figure 5. So when we are talking about figure 5, the conclusions that we can make in figure 5, the conclusions are as follows. Carbon dioxide concentration stayed constant from 1850s to 1900. You can show it from here. 1850s to 1900, the carbon dioxide concentration stayed constant. You can see after that, from 1900 to 1950s, it's gradually increasing. And from 1950s to 2000, it increased rather exponentially, and it kept still increasing exponentially till today. So the answer can be point number 1, carbon dioxide concentration stayed constant from 1850 to 1900s. Carbon dioxide concentration slowly increased from 1900. Carbon dioxide concentration increased more rapidly from 1965 onwards. Table 2 gives the information about 4 alcohols. Which alcohol in table 2 is liquid over the greatest temperature range? We have to see where we have the difference. For example, 65 and 94. All right. What is the difference in melting point and boiling point? So when we see that, we find out that it's 65 plus 6 degrees Celsius, which gives us 71. The next one, in order to find this range, we'll actually have to add this value as positive. So obviously 94 plus 65, all right, ethanol 118 plus 78, propanol 128.97, which is like the highest. So the greatest temperature range is for propanol. Guys, if you haven't understood why we are adding, any number that is below 0, for example, minus 100, and any number that is above 0, for example, positive 100. If we are going from a distance of minus 100 to a distance of positive 100, then that distance is total 200. We have to add these 2 numbers to get the original value. And then it becomes pretty straightforward that adding 2 bigger numbers will give a bigger. Which statement is correct? A molecule of ethanol has 5 hydrogen atoms. So let's see, a molecule of ethanol, total of 6 hydrogen. 3, 2, 1. So 6 hydrogen atoms. This is not correct. Butanol has the highest boiling point. So we can see butanol having, no, it does not have the, okay, yes, it does have the highest boiling point. It has 118 degrees Celsius as a boiling point. So butanol has the highest boiling point. This is correct. A molecule of methanol has 5 single covalent bonds. Draw the missing bonds in figure 6 to complete the display formula of methanol. A question like this, you have to understand a carbon has the ability to make 4 bonds in total. So there will be one bond between hydrogen, one bond between each hydrogen, and one bond between oxygen. Oxygen has the ability to form 2 bonds, and hydrogen has the ability to form only 1 bond. Keeping that in mind, you'll get it very clearly. Figure 7 shows flow diagram for the process to produce ethanol. Steam plus ethene is reacted in a reactor, and then it produces gas. The gases are cooled. The cooled gases are put back into the reactor. The process continues, and a mixture of ethanol and water is produced at the end of the process. Complete the word equation for the reaction to produce ethanol. So if we are using steam plus ethanol, steam is water, right? So it's water vapor. So we're just gonna write ethanol plus water. Sorry, ethene plus water, that gives ethanol. What happens to the unreacted ethene? So the unreacted ethene, as we can see in the process, is always recycled back into the reactor. It's not thrown away, so it's just recycled. We can say recycled, or it can say goes back to the reactor because it was written in that way. Wine contains ethanol. A bottle of wine was left open in air. After a few days, the wine tested of vinegar. Vinegar is a solution of ethanoic acid in water. Explain how oxidation causes wine to taste vinegar after a few days. Generally, air contains oxygen, and when ethanol is exposed to oxygen, alright, if there is certain bacteria present, then the ethanol oxidizes, which produces ethanoic acid. And ethanoic acid is what that gives the wine its vinegary taste, alright, or in taste of vinegar after a few days. Guys, that's the end of question number 6. Thank you for watching the video. See you in the next video.